Hey everyone, this is Judy Warner with Altium's OnTrack podcast. Welcome back to another podcast session with us. As always, we have another incredible guest with us today. But before we get started, I wanted to invite you to please connect with me on LinkedIn. I'm very active there and share a lot of resources for engineers and PCB designers. And also, I don't think I shared this in past podcasts, but we are also recording this on YouTube as well as just an audio. So you can always go to YouTube and go to the Altium channel, look under videos, and you'll find these also in video format if you should prefer to listen to this and watch it in video format. So, and also with Altium, you can always follow us on Facebook, LinkedIn, or Twitter, and we love engaging with you, and we always would love to hear from you about subject matter experts or subjects you'd like to hear or learn more about. So, without further ado, I'd like to welcome our guest today, who is Dwayne Benson of Screaming Circuits out of Canby, Oregon. Correct, Dwayne? It's Canby, right?
It is Canby. That's correct.
Canby. So, Dwayne, welcome. We've crossed paths for several years now, and it's a delight to have you and learn more about Screaming Circuits and EMS and sort of how designers can do things to be more effective in the design for assembly and just learn about Screaming Circuits model. So, which is a very unique model, by the way. I'm eager to jump in.
Well, thank you. I'm really happy to be here. Thank you for asking me to participate in this.
My joy. So, why don't you start out by telling our listeners a little bit about who and what Screaming Circuits is, because it really does have a highly unique model and kind of the why behind you guys started the company and created this model.
Well, it started back in 2003, actually. What's that, 15 years ago now? Yikes.
I know. How did that happen?
So about that time, our parent company, Milwaukee Electronics, they had a number of customers that were struggling to get small volumes of prototypes put together. Back in the olden days, if I can use that term, prototypes quite often were sort of slotted in on an as available basis. So right. You say, you might need 5 prototypes, and the EMS company would say, well, I've got a big run going on, and I can put you on the machine in 2 weeks, so you can get your prototypes then. Mm-hmm. And 2 weeks come along, and something else came up, so another week. Even going back even before that, like back in my days at InFocus, for example, building a prototype, we'd have a big bag of parts and some blank circuit boards, and we'd hand them to this poor technician on a Friday afternoon, and the engineers would say, can you have these built up by Monday?
Yeah.
Well, yeah. So it was becoming a real struggle to get prototypes, get small volumes of any sort built. And a couple of our customers came and asked us and said, can you help us out with this? It's just not working. And the Milwaukee Electronics management thought about it a little bit and thought, gee, why can't we short circuit the process? We experimented.
No pun intended, right? You weren't short circuiting the part.
Well, we may have been, but hopefully not too often. So the management experimented a little bit and then decided, there's an actual business here. So back about that time, they brought Jared Storr out here to start up what they called the Screaming Circuits division to focus specifically on getting prototypes done quickly. Mm-hmm. And from that time, the initial focus, the initial business was basically Jared with email and a phone, and one of our partners, Sunstone Circuits, they build the blank circuit boards, the raw fabs. Mm-hmm. They'd give us a call and say, hey, one of our customers needs some prototypes built. Can you guys do it? And that's how the business started.
So you guys created the synergy. Now, I've had the pleasure of meeting Jared once, at least through the phone and email. or phone. And Jared was young, right? Wasn't he the son of the owner? So I have to
Yes.
insert that because I kind of love that. Those of us are kind of old dogs in the industry. I kind of love that he said, well, why can't we do this? And he just, kind of like you said, a phone and a thing, and
Yeah.
just said, why not? Because he wasn't constrained by the way things were
Right.
done in the past, which I kind of love that.
Exactly. He was a young entrepreneur. In fact, I don't know if he'll want to admit this, but this was his first job out of college. This was kind of an experiment for him to get into a career into business, and he did a fantastic job,
He did.
basically by ignoring all of the old rules.
I know. Yeah.
Yeah, yeah. And then in 2004, well, somewhere between late 2003 and early 2004, we first went online with a very, very simple quote system. We boiled it down into 6 different factors, and based on that, came up with a quote. And it was all kitted at that point. So we'd say, hey, it's going to cost you this much. Send us your kit, send us your files, and we'll build them up for you.
Now, since that time, when we were talking earlier, it seems like it's morphed into not just specifically prototypes, but just quick turn. It could be quick turn, pre-production, quick turn, production even, right?
Mm. Yeah, the world of manufacturing of electronics has really changed in the last decade and a half. You, you know, there was a time when electronics were not going to be designed and built in this country. Back in the 90s, when I was working for Infocus again, everybody was outsourcing everything. And then over the next decade after that, it was all going away.
Yeah.
And there was going to be nothing but high volumes manufactured offshore. Well, about the time we started doing this, coincidentally, the open source hardware movement came about with the Arduino and some of the other things that came with that. Kickstarter showed up, and that really changed the hardware design dynamic. It lowered the barriers to entry to building a hardware company, and over the last decade and a half, the hardware startup has come back with a vengeance. Problem is manufacturing is really, really expensive unless you're doing super high volumes. So these companies they'd run a Kickstarter, they'd sell 1,000 of an electronic board, and nobody would build it for them. So they'd run off into Asia, and they'd tour all these shops, and these people would either say, no, that's not enough, or they'd change the design, steal the intellectual property. You can't.
Yeah, there's that.
Yeah,
IP
details.
was that?
little details like that. So getting 100 or 1,000 or 5,000
Right.
built is extraordinarily difficult, and yet there's an awful lot of companies that sell just that many of something.
Yeah. It's really interesting that it kind of morphed into that niche, right? That
Yeah.
you had, it sounds like you had everything sort of in place to sort of fill it, right? You'd built it to address prototype, traditional prototypes, and as the market changed, you were kind of ideally positioned to address those kind of startup Kickstarter things. And then so you and Sunstone have worked together in parallel, I take it, throughout this process?
Yes, they've been our partners since the beginning, and at this point, they build the vast majority of our circuit boards. We do, if necessary, go elsewhere, or if a customer sends us the boards or requests something else. But the vast majority of our boards are built by Sunstone. They're about 10 miles away over in Malino, Oregon.
Another big city like Canby.
Yeah. Well, compared to Malino, Canby is the big city. So.
Yes. Well, it's a beautiful area. So tell us about kind of what you would see in a given day. And then I would like to ask you to jump into speaking to designers that may be listening and go into kind of some DFM tips and tricks. But before we do that, tell us about what are you going to see in a day?
To get a picture of what happens here at Screaming Circuits, there's two factors that are pretty important. One is a traditional EMS company. We see about as many different jobs through here in a week as a traditional medium-sized EMS company will see in a year.
Wow.
And the other factor that's important to notice is that, again, using that term, the olden days, getting a quote and an order for a project might be a 3 to 4 week process, going back and forth with all the files, component availability, making sure the design works, and then after you place the order, you've got the NPI process, which is another 3 to 4 weeks. So you've got a 6 to 8 week process that we do in 6 to 8 hours.
How is that possible? I mean, we may not have enough time here, Dwayne, but I've been in the EMS industry, and it's an extremely complex process. Just getting the components you need and making sure they're right, and there's not obsolete parts, and that you've got a clean BOM, and it's so complex. How have you condensed it without giving away your secrets?
Well, there's a lot of things that matter if you're building 100,000 of something, or 1 million of something. At that point, fractions of a penny count.
Right.
And you're going to spend a lot more time quoting. You're going to have to worry about getting large quantities of components. If you need 20 of a board, you can go to DigiKey and get the parts for $1 that would cost you a quarter of a penny if you bought them in high volume, and that's still fine.
Okay.
That's a big part of it. And then you don't have to worry about some of the inefficiencies that would absolutely kill a high volume manufacturer. You don't have to worry about those, because if you have to tweak things by hand, while that is more expensive per unit, if you're building 20 or 100 or 1,000, it doesn't matter quite so much. So really what we've done is we've stepped back and we've said what is important and what is not. The objective is to get working boards into an engineer's hands as quickly as possible. And you'll notice there aren't things like how do we make it the absolute least expensive, or things of that sort. It's about getting the working boards as quick as possible. So you focus on just the things that matter for that.
Right. You mentioned when we talked a few weeks ago about it kind of becoming what you had called a transactional model, which is really different in our
really
industry.
Is.
And to where you can go online, place your order in a very transactional fashion, but it also speeds up your time to market, right? And
yes,
gives you something highly valuable.
Yes, it does. We don't spend an awful lot of time on the financial component of it. For the most part, you give us a credit card and we start building. So we don't have to worry about the bank component of it. For larger companies, we do,
right?
Because some people, the government, whatever, they have to operate that way. But for the most part, you just give us a credit card and we go. That again cuts some time out of it. We also look at each order as an individual transaction. That's why we call it transactional manufacturing, or unforecastable. We don't have to worry about the fact that you're not going to need exactly 500 every month for the next 24 months. Traditional EMS, you have to worry about that. You plan for that. We don't worry about that. We don't care.
Yeah, it's interesting. It's a great model, and I see it as a real enabler. So congratulations to you guys. All right, let's dig in and give our listeners that are designers and engineers some tips around DFA. I guess DFM, DFA. The way that you and I originally came to know each other is I had been blogging and writing, and then I came across little publication you put out called Circuit Talk,
Mm-hmm.
in which you were doing sort of what I was doing, which was giving designers, some really immediately tips to apply to make their jobs hopefully a little bit easier. And so I think you've done a really nice job of that. So can you talk about why you started Circuit Talk, and then go ahead and share some of those tips or tricks that are around design for assembly that's going to make designers' jobs easier and smooth the time to a good product and time to market?
Well, thank you. The volume of jobs that we get, it does lead to chaos of sorts, but it also is a huge advantage in that we get to see every single mistake that anybody's going to make. We don't specialize in a vertical industry, so we don't only see mistakes related to a certain type of componentry.
Oh.
Name a component that's leading edge, we've undoubtedly seen it. And so we see these things, and it's not just beginners, it's not just experienced designers, it's not just big or small or university. Everybody makes the same mistakes. It's so complex, and there are so many variables, so many new types of components, geometries are shrinking, and in parallel to that, people have less and less time to design these things. Quite often, layout isn't taught in schools, or it's self-taught.
Yeah.
The experts who knew exactly how to make a layout work perfectly have retired now, or they've been let go, or things have changed so fast they can't keep up.
Mm-hmm.
So we see these problems every day. Case in point, one that I write about quite often relates to the QFN, the quad flat pack, no lead, and then the DFN. The DFN leads along one side. They have this big metal heat slug in the middle. Looks like a very simple component. It's cool. It's small. Has great signal characteristics, but most of the CAD software, when you try and use a QFN, the footprint is wrong. It comes from the library with the solder paste layer not designed specifically for the component. So imagine flipping a QFN upside down. You've got a little row of contacts around the outside, very small, and then a big giant heat slug in the middle.
Okay.
That covers almost the entire component. So most of the library components we found have a full aperture opening, so the solder paste layer is completely open for that heat slug in the middle.
Oh, no.
And what happens is you end up with too much solder in the middle, so the part floats up, and the contacts on the side don't
disconnect, or
they don't connect.
Oh boy.
Yeah, and this is even more prevalent with you see some of the open source CAD software, or some of them with a lot of user generated content. Nobody told those folks how to make the footprint properly.
I see.
Quite often the manufacturers in their data sheets even specify it that way. But what you need to do is you need to modify the footprint. So in that center pad, you get somewhere between 50 and 75% paste coverage. So you take out the default paste layer for the center pad, and you put in a little window pane looking thing. Problem solved.
I see. Interesting. It's a little scary, unless you have a partner that's on the ball, to that what you can accidentally pick up off a data sheet.
Yeah.
Or how to interpret that data, right? So, okay, well, that's a good one. Go ahead.
Oh, I was going to say another one we run across are these tiny little micro BGAs, 0.4 millimeter pitch, some of them even 0.3. I've actually seen a 0.24 millimeter pitch BGA.
That's crazy.
Yeah, some of the rules change. With the bigger BGAs, you want non-solder mask defined pads. So you want the solder mask opening to be slightly larger than the little pad where the BGA ball is going to sit down.
Yep.
With some of the 0.4 millimeter pitch BGAs, you want solder mask pad or defined pads. Otherwise, you get bridging.
And, yeah, that makes sense.
Yeah, it kind of depends on the geometry of the solder ball, but that's a pretty common error as well. So you see these things that component manufacturers haven't fully studied, haven't fully published, and yeah, they just are setting people up for problems.
Well, and what I have found, and not just in relation to components, I have talked to people who manufacture either components or they manufacture laminates. And what's not widely understood is that sometimes the studies they're doing is us.
Yeah.
We're their guinea pigs.
Yeah,
And then
yeah.
we yell and scream and we give them back data, and then they produce overtime accurate data sheets. And I was stunned to hear that, but it's absolutely true. They need to get stuff to market because the market's demanding it, right?
Hmm.
And the testing is so complex and so widespread, and the applications are so widespread that they can only go so far.
Right.
And then the rest of the data has to come from real world.
Yeah, yeah. The
And
hardware industry really is paralleling what the software industry did. We had open source software, then open source hardware. With software, we started calling it beta test the world because you couldn't beta test anymore. It's too
right,
complex.
it's too
Same thing.
complex. So we become the beta testers. And
Yeah.
I don't think that's often understood. And when I first understood it, my jaw about dropped. Like I was like, what? Because I'm from the old school like
Mm,
you are, and it's like, wait, nothing would ever go out that was not fully vetted, understood,
mhm,
tested, and things have just gotten so complex and so that there's just a hard limitation there. They're not
mhm.
It's not a bad business practice, whatever, but it's a reality that I think is
Yeah.
wise for designers and engineers to keep in mind
Hmm.
that and again, another encouragement to work closely with
Yeah.
people like you that can say, we've seen this already a bunch of times and we
Yeah.
know what's going to occur here.
Yeah. We've built our whole business around everything being wrong, basically. It sounds kind of funny, but we have. That start to finish, it's all about this stuff probably isn't going to be right coming into us, so we've got to figure out how to make it work.
That's, I don't know, like what happened to the world? Dwayne, this is not how we started, but here we are. Another thing, you talked to me a little bit about, you had mentioned one time in a conversation about polarity markings.
Oh yeah, that's maybe third or fourth in terms of the issues that we see here. Um, with diodes especially, capacitors somewhat, but diodes even more so. Any kind of ambiguity, when you're dealing with machines, it's a problem. If you've got a barrier diode, for example, it's backwards from what you would consider a conventional diode. So if someone marks it with a plus, and it's a barrier diode, and they're expecting us to know whether the plus goes to the anode or the cathode, we're going to put it in the conventional manner, not knowing it's a barrier diode. It's going to be backwards.
Oh.
Uh, so you can't use a plus to mark a diode. You might think minus also. Well, does that mean negative, or is that the line on the diode symbol? You can't do that because it doesn't tell us anything. You've got to say K for cathode, not C, because then we might think it's a capacitor. So K for cathode, or the full diode symbol down. Um, if you use a lot of people will put in silkscreen the mark that's on the bottom of a surface mount diode,
Uh-huh.
which at first glance seems like, well, that makes a lot of sense too, but only if you give us the exact diode that you got the marker off of. I've seen two diodes, 0603s, in the exact same package from the exact same manufacturer, just a couple characters off in the part number, and literally on one the mark is the anode mark, on the other it's the cathode mark. I've got a data sheet, and I have a clipping from that data sheet on the Screaming Circuits blog that shows that it's got this part anode mark, this part cathode mark. I made the same mistake myself in one of my boards. I put the little marker on there, and gave the company the orientation and the CAD files, and then I made a substitution because one part was no longer available and used the other one. Same thing,
Ugh.
but it was backwards because I went from cathode mark to anode mark. So remove ambiguity. A few years ago, I would say it's okay to mimic the silk screen, just give us the exact part. But with supply chain availability being such an issue right now, I would not rely on the mark that's underneath the diode because they can reverse if we have to substitute something.
Okay, I'm going to put a pause there and talk about what the heck is going on with supply chain stuff about diodes, like these very basic building blocks to design. Why are we having problem sourcing parts that are
Well, we've been told a couple of things from suppliers. One is they're telling us that the automotive companies are buying up literally an entire line. They'll come to a component manufacturer and say, this particular part, I need all of your production, all of it. And so there it goes out of stock. Internet of Things companies, the super hypermobile devices are also causing issues because they're increasing the demand in the super small components. Well, then the companies that make the parts don't have fab capacity to also make the larger ones. So we're also telling us, some of the component manufacturers are telling us that they're going to stop making some of the bigger form factors. So 1206s, 805s, even 603s may become even more and more scarce because if they can make an 0402 or an 0201 to cover all of that range, they'll do it and not make the other form factors.
I don't know what to say about that. Like, I'm like, if I was a designer engineer, I'd be freaking out. Like this puts people in a really tough spot.
It really does, and it's going to change the way some things are designed. We have always had a policy that we will not substitute anything without explicit approval. Even looking at a bypass capacitor, a 0.1 microfarad 16-volt bypass capacitor.
Mm-hmm.
In some cases, you need exactly, there's some parameter that you need to be exactly the same, so you can't substitute. But there are also plenty of cases where it's just sort of by guess and by golly. Well, yeah, it's a 0.1. It could be a 16 volt, 10 volt, 25 volt, 50 volt, whatever. If that's the case, people are going to have to start being really flexible in terms of what they will accept for a component. And maybe at some point the industry will have a flag on a bill of material that says this one's engineered so it has to be exact. This one, just make it close.
That's
Otherwise,
wild. Another thing, our industry is changing so fast.
Mm-hmm.
Which is a big reason why LTM and I, decided this podcast would be a good idea. The same reason why your Circuit Talk publication is a good idea, because it's like we can't get the education out fast enough, or, get the news out like, holy cow, why can't I get this capacitor? Like,
right.
What? It's not a unique form factor specialized BGA, they're capacitors.
Right.
This was like, your bread and butter. It's been puzzling to learn about that, and I'm just really interested to see how these component manufacturers are going to deal with this, and again how designers are going to be forced to think hard about these parts. It's really strange. Anyway, sorry for taking a little side trip there, but
that's important. It's a significant issue, and we're being told this could last until 2020. And
what?
when we get out of this allocation, the industry is going to be different. And as I said, a lot of the bigger form factors consider moving all to 0402s. It is more difficult to deal with these smaller ones. But those are the ones, when the component manufacturers catch up, it's going to be in the smaller form factors because they can sell them to people building small devices as well as big. So think about that. Be very, very careful when you're picking the specific component, and tell us and other manufacturers like us what parameters are important.
It's a great tip. I hadn't thought about till just this minute when you were talking. I'm wondering if this will drive an uptick in embedded.
Embedded passives.
Uh-huh, embedded passives.
That I don't know. I've been waiting to see that. I joined this company in 2005, and embedded passives were in the news at that point. And I actually made a prediction on the Screaming Circuits blog that in 10 years, I think I said 80% of the passives would be embedded passives. I don't know that we've ever seen one.
Really?
Although I guess technically you wouldn't see it because it's inside the circuit.
No, but you would know it was there because I know it from my board manufacturing background. You would know because you would have to process it differently. It's a different process. And I don't know what the cost trade-offs are there, but I've met like Bruce Mahler from Omega, and I've met some of those folks, and I'm just wondering, it's just, moment, like wondering if this allocation will drive, but I don't know what the cost trade-offs are or performance comparative. That makes me think I need to call Bruce Mahler and get him on the blog because it's an interesting thing to ponder, right? In lieu of what's going on in the marketplace.
Yeah.
Anything else you would mention off the top of your head that's something repeatedly you see that's a design for assembly thing, like that you would recommend designers to take a look at closely?
Well, the polarity, the QFNs, BGAs, as I mentioned, something that isn't necessarily quite so obvious is the data files. That is an important part of design for assembly. Ambiguity on a board is bad. Ambiguity in a data file is bad. A bill of materials, if there are parts in there that don't match the board, that's probably 80% of the jobs that come through here have some sort of a bill of materials issue. So double check that that's accurate and that it matches your CAD files. If you can give your manufacturer the intelligent CAD files like an ODB++ or IPC 2581, that significantly reduces the chance of error. But then there's a little irony in there too that a lot of board houses still prefer Gerbers. So we have seen cases where someone saves and then, I can give you the ODB++, but they forget they've made a slight change. And so now we have Gerbers don't match the ODB++. So make sure all of your files are consistent. Make sure the bill of material is clear and finalized. All in all, if you add up all of the files issues that we see, that's probably one of the most common problems. I mean, I run into those problems for myself. I design some boards and run them through the factory here, and I know how to do this. And in theory, I know how to do this.
Right.
And I regularly make mistakes that my coworkers chide me for.
Well, nah. Well, I think, again, that leads to the complexity, the data that's available, the data sheets, whether they're right or... I mean, it is such a complex thing, and it amazes me that we can even manufacture a circuit board and then put components on it and come out right workable sometimes because it is such a complex process. And I'm really glad that actually I appreciate it. I don't understand all those steps, but having worked for both a really high-end EMS that sold to tier ones, very complex boards, and also having worked for a variety of board shops, I really appreciate the complexity in both those disciplines. And I think sometimes because a board shows up as a line item on a BOM, that complexity sometimes can get lost on you. But when we're building things, even here at Altium, into our own tool that helps, like an active BOM and things like that hopefully, I think design tool manufacturers like us, I think we're doing a better job of, helping in that regard, right?
Yeah, definitely.
Well, the last couple items I wanted to talk to you about. Well, thank you for all that, by the way.
You're
And
welcome.
again, we will share in the show notes your website, the circuit talk, and I would recommend to anyone who is listening or watching that you subscribe to Dwayne's blog or just Circuit Talk or whatever. And we'll put all the links in because, again, he's got his feet in the fire and runs up against these things, as he said, because they're putting through such a width of products. Like I used to work for an EMS, and like you said, it was a vertical.
Hmm.
So we worked with, military, tier one.
Hmm.
And so the type of boards we saw was, you know, a niche, right?
Yeah.
You're seeing everything.
Yeah, literally. I mean, we worked on a camera board, the electronics of it for National Geographic. It sits in a plexiglass globe. They drop it to the bottom of the ocean. It's got a chain on it, and when the chain rusts through, the camera bobs to the top, and they pick it up again. We've got stuff on the being built for the 2020 Mars rover. So literally down in the ocean, up into space, and anything in between. We've built Arduino-based stuff, real simple things, through hole. We built a board with 5,000 placements. It's all over the place, and it's just absolutely the most fascinating place I've ever worked. Certainly
Right.
because of that.
Yeah, I could see
Yeah.
that. I could see it. And again, kudos for you for, you know, it's easier to do a quick podcast or write a blog post or produce a circuit talk that can go out to thousands of people and get that information out in that kind of global sense and be helpful, right?
Yeah. Yeah.
Rather than tell one person at a time, right?
Exactly.
It's kind of the
Exactly.
scalability of getting that knowledge out. So I really appreciate what you've done over the years. One thing I wanted to ask you about, which was a fun thing, is about, I don't know, 6 to 8 months ago, I had the privilege to go with the Altium team for the first time to a maker fair because we have Circuit Maker
Mhm.
and Circuit Studio. Circuit Maker is free.
Yep, I've
And
used it.
and now we've bought a company called Upverter, which is also free and in the cloud. And we also have Circuit Studio. So we went there with those products. And because of my position here as a director of community engagement, I hadn't had any exposure really to the maker community, other than seeing stuff online.
Yeah.
And I went, and it was like drinking from a fire hose. It was so much fun. Goofiest things, people, like
Hmm.
it was so much fun. So I'm walking the aisles, kind of collecting things to write about or learn about. And I come across Dwayne Benson wearing what looks like wrap swag around his neck. It was like a clock you were wearing, right? Or something. He looks like a
Yeah.
rapper. And I'm used to thinking of him as this Dwayne Benson from Screaming Circus. And here you are, like fully immersed in the maker space. And you had designed this
Hmm.
device and had LEDs on it. And I'm like, what are you doing here? So tell me about um, how you've come to serve makers. It doesn't seem like, from a profitability or a business model, that would be a market that a company like Screaming Circus would address. So how'd you get there, Dwayne?
Well, you could say that I'm a bit of a method actor. I mean, I've been designing small circuit boards for a very long time and writing the software for them for a very long time. And one way of looking at it is I'm a hacker and a maker who happens to be lucky enough to have a manufacturing facility that I go to every day. But more specifically, those hackers and those makers, they are starting businesses,
Yes, they
and
are.
many of those businesses become our customers, whether they be crowdfunding or bootstrapping or getting investments. They are the future. The maker community has a lot of students in it. It has a lot of weekday engineer, weekend hackers. It
Oh,
has a
mm-hmm.
lot of people who aspire to start a new business, and just such a wealth of creativity. And part of our mission, I always like to look at. I'm just one person. We're just one company. But if we can make our tiny little corner of the planet just a little bit better, then we've been successful. And all of those people who want to design electronics,
Mm-hmm.
we know what they don't know. We know what kind of problems they're going to run across before they do. And
Right.
so if we know what they don't know, why don't we pass that off? And some of those people will have boards built with our competitors. Some of them will build them themselves. Some of them will have us build them. Whatever. We're helping them understand this industry better, and we are helping them, build better boards. That's what we really want to do. That's why we're at the maker fairs. Ultimately, it does always have to lead back to more business for us, and it does.
Right.
The you know. People see Screaming Circuits there. They get the Circuit Talk and they read it, and it's Circuit Talk, a Screaming Circuits publication. So all of that winds its way back eventually to helping the business here, and that's how we can afford to do it. But if we can help the business, build and grow the business, and help these budding designers,
Mm-hmm.
that everybody wins.
This is why I love you and love you guys. I love that philosophy. I love that approach. I try to live by an old Zig Ziglar thing, and this reminds me of you and Screaming Circuits model that you just explained. Is Zig Ziglar used to say, you really can have everything you want in life if you just help enough other people get what they want, right? So it's kind of knowing and consciously that if you put good things out in the world and you do the right thing and you're ethical and you have integrity and you serve people, that good will come back to you, and you'll do okay. And I think that's a big key to your success, actually, by kind of leading with service and not ignoring the bottom line. We're in business to make money. We have to do that or we're not in business anymore. So I
Yeah.
really appreciate that. Well, we're wrapping up now, and I think you've listened to a couple of these podcasts now. And so 2 questions for you. One,
Mhm.
are you a nerd or a geek?
I'm a gnerd.
That's the best answer I've ever gotten. Yes, you're a nerd.
A gnerd. Yeah. There was a time when those were really pejorative terms, but I think nerds and geeks have taken it back, and
Right?
we've said, what? No, we're not going to be ashamed of liking technology and loving it. We're proud of it,
Right.
and yeah,
So
I'm
you're
a
a good
gnerd.
nerd. Oh my gosh. I'm totally going to steal that and use it somehow, Dwayne. That will come back to haunt you later, I promise. Um, and the other question is, but I think I know the answer, is if you've listened to the podcast, I always ask designers and electronics professionals in the end, this is Designers After Hours. So because there is so much creativity involved, a lot of people, like you said, are makers or hackers, or they play a musical instrument, or they're sculptors or whatever. So what is your kind of guilty pleasure that you like to do after hours?
It would have to be photography.
Oh,
I chase animals around and take pictures of them. Animals, landscapes, and then have sort of a weird passion for old, decaying industrial sites as well. But photography would probably have to be my passion when I'm not playing with electronics.
that's so cool. Do you have a website where you share any of that, or it's just mostly a personal stuff that you keep your photos and share them with friends and family and whatnot?
It's mostly a personal thing. I have had them on websites before, but
Yeah,
it's just
personal
really
hobby.
it's my thing. Yeah.
And what do you mean about industrial sites? Like,
Well, old decaying industrial, rusty factories. There's a place here in just north of Canby called Oregon City, and we've got a waterfall on the Willamette River. And most people think of waterfalls as pristine and nature, and that's all wonderful. I love that. But this one, back in the 1800s, they started building paper mills, and they built a set of locks. It's the oldest, well, until they just recently closed it down, it was the oldest continuously operated locks west of the Mississippi. And so now you overlook the river from a nice restaurant, and you see this shut down, decaying industrial plant. And, well, no, it's not the beauty of the river, but I see a sort of beauty in the symmetry and in the way people constructed these things. It's almost like an architectural dig. You can see things from 100 years ago, from 80 years ago, from 60 years ago, and you can see the evolution of that as the thing built up, and then as they abandon it. And there's just, for some reason, I really enjoy that sort of view, as well as, the natural natural views as well.
They do have a really unique aesthetic, and things have changed. It is kind of like a little time capsule, and the rest is actually beautiful. And sometimes the design itself is beautiful. And well, thank you again. This has been fabulous, and I'm sure we can talk more and more, but thank you so much for giving me so much of your time and sharing DFA tips and the story of Screaming Circuits. And we wish you continued success, and we'll certainly share the website and Circuit Talk, and if there's anything else you'd like to share with us, give me a holler and I'll make sure we include those in the show notes.
Well, thank you very much. It's been a privilege to be on the show here.
Thank you, Dwayne. Again, this has been Judy Warner with Altium's OnTrack podcast and Dwayne Benson from Screaming Circuits. We look forward to seeing you next time. Until then, always stay on track.